Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, you realize that this video was already uploaded, where we calculated the required things here. So we went through a free body diagram, finding the dependent and independent, then 5.3 stating work, energy, and power, and now 5.4 calculating the mass of the trolley using WNet. But now, what one thing I've realized is that in my questions I haven't been using this formula of WNet, or rather work done by non-conservative force. It is equal to changing K plus changing potential energy. Now I want us to go through that alternative step. Now let's take this as step one, or rather method one. Let's go through method two and see. Some people might be interested to seeing how that formula works. So we're gonna say for method two, we're gonna say work done by non-consecutive force is equal to change in K plus change in U. But more or less, you will see that these formulas are the same, especially in this case. Now, why am I saying that? All right, remember work done by non-conservative force, we're gonna take applied force, friction, tension in this case. But we realize that in this case we had only frictional force from our free body diagram. We only had what? Frictional force. So we're gonna say under work done by non-conservative force, we're gonna say it is work done by frictional force, which it is equal to what is changing K? Half mv squared final minus half mv squared initial. But remember, what's a formula form? All right, let me do this. Plus, what is the formula for changing U? Changing U, remember, it is potential energy. It is mgh final minus mgh initial. But I want you to realize something in this case. My object, it is moving on a flat surface. Let me remove this. My object, it is moving on a horizontal rather, not a flat. Yes, it is moving on a flat, but that's not important. It is moving on a horizontal surface. So I know on a horizontal surface, I only have the distance, or the what? The change in x. Do I know the change in y, which is my height? Yes, I do, but that height, it is how much? Remember, it is 0. It is at the ground here. It is at the ground. So my height here at the ground, on this point, it is 0. So everywhere where my trolley travels, my height will be how much? Will be 0. So what does that entails? So it tells us, so even if we were to go back to our formula here and substitute here, the height final, it is 0. We all agree? The height initial, it is 0. So it makes all these things to become what? To become 0. So we end up having work done by friction, which is friction, change in x, cosine of my angle, it is equal to half mv squared final. But I know what is half mv squared final. Half mv squared final, it is 0. Let me do this. Half mv squared final, this is 0 because remember, therefore it's like this, therefore then because it's like this. All right, because why? Because my final velocity was given me to 0, because they said it came to rest. So this is the same as saying f changing x cosine of theta, it is equal to how much? It is equal to negative half mv squared initial, which is, even if I did not need to do this and say it is equal to negative initial kinetic energy. And I know that if you realize here, what we have here, we have the same thing. Let me just substitute. What is my frictional force? My frictional force, I think, was, or instead I was given mu k. So it was going to be mu k multiplied by normal force, but my normal force, it is equal to mg in this case. Therefore, my change in x cosine of my angle, it is equal to negative initial kinetic energy. I do not need to derive this or make it whatever, do it half mv squared, because why? I have the kinetic energy. So I'm going to say, what is my mu k? My mu k was 0.18 multiply by my mass multiply by 9.8 multiply by What is my change in x? I think it was 1,5. Let me just confirm. Or my change in x was 3. Or I can, or another, yes, this is also good. Remember I said you can use 3. You can use 3 here. I remember saying you can use 3, but it should match your corresponding what? Your corresponding kinetic energy, which we used what? 12 in this case. Again, but now that we choose 1.5, now that we choose 1.5, let's see if our answer is going to still be the same now. We want to see that if whether our answer is going to be the same. This is good because now it can improve the accuracy of our answer and the accuracy of the investigation. Let me grab my calculator. So if I use 1.5 as my change in x, I'm going to use -6, or rather 6 as my what? As my kinetic energy. So I'm going to come down there and say, all right, if I'm using my 1.5 here as my change in x, cosine of my 108. Remember I said friction always it is 108. It is equal to negative. What is my kinetic energy? 6. So I'm going to say on my calculator 0,18 multiplied by 9,8 multiplied by 1.5 multiplied by -1. So it's going to give me 0,18 multiplied by 9,8 multiplied by 1.5 multiplied by -1. That gives me how much? That gives me -2.646 watt m. It is equal to -6. I know these m's will cancel. These m's will cancel. This m will cancel that m, not the negative rather. Then now, therefore, my m it is equal to how much? Let me see. I'll say 6 divided by 2.4, 2.64664,646. I get a value of 2,267. But I know two decimal is going to be how much? 2,27 what? Kilogram. Remember in physics, we use kilogram. In chemistry, we use grams. Now look, here I got my mass as 2.27, and also here I got my mass as what? 2.27. So whichever method that you use and whichever value data, as long as it corresponds here you use, is gonna give you the correct answer. So that's all for today. I wanted just to include that. Thank you very much, folks.